Hi ladies and gentlemen, welcome back to the JSsifu channel. And today we are going to do an intro to recursion. Now, what is recursion?
In computer science, recursion is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem.
So now we are very clear on what's a recursion, right? Alright, so now we're going to look at a recursion function. What's a recursion function? What? A recursion function that is a function that tries to solve a problem that keeps calling itself again and again until it reaches the base case. Let's go for an example. Let's say you want to find the factorial of a number. Okay, what's a factorial?
Oh, yeah.
So the factorial of a number is the product of the number from its sequence. So let's say the factorial of 4 means it's equal to 4 multiply 3 multiply 2. Ooh, marker is going off. And multiply by 1. So what's that equal? So 4 multiplied by 3 is 12. 12 multiplied by 2 is 24. 24 multiplied by 1 is 24. So factorial of 4 is equal to 24. Right? This is the end result we want to get. So what's the factorial of 3? You say, what? 3 is the biggest number, so it's going to equal to 3 times 2 times 1. You see the pattern? It just go from the number, multiply by the 1 minus that number, which is 2, multiply by 1 minus number is equal to 1, right? So we go from the number towards 1, and you're going to get the product of all the numbers. And we can solve this problem with recursion. Okay. So now we're going to do a factorial function. This factorial function is a recursive function, okay? And now we have some test case right here for some numbers. Now we have the factorial function, we have input n number, and n is always bigger than 0. Just keep it simple, right? N is always a positive integer. And then we have some test case right here. Factorial of 4 is 24. Factorial of 3 is 6. Factorial of 2, we know that 2 times 1 is equal to 2. Factorial of 1 is equal to 1. And now when you think about recursive function, what's our base case? If you look at our input parameters, right, we know that n is bigger than 0. What is the first number that comes to mind? The number that's bigger than 0. It's 1, right? N is equal to 1. So what if a user say, they run the function, invoke the function factorial of 1. What should we give them? That's not much of calculation, right? Because if n is equal to 1, then you just return 1. Simple as that, and that's our base case right here for the recursion function. Okay, now, so we have our base case as the input is equal to 1. So what's our next step, right? Well, our next step to solve a recursion function is to think about what is beyond the minimal case, right? If 1 is the minimal case, now the next number we have is 2, right? 2. Factorial of 2. What should we give them? We know that 2 is given as our input, and we know that we need to use 2 as one of the number to multiply. We use 2 multiplied by 1. What is 1? Right? 1 is the factorial of 1. Think about this. So now you have 2, right? We have n. N is 2 at this moment. And we multiply by 1. Right? Where do we get the 1 from? It's actually 1, since n is 2, then 1 is n minus 1. Is that right? If n is equal to 1 is equal to n minus 1. So we will say the factorial of 2 is equal to 2 multiplied by the factorial of n minus 1. Now we have n times the factorial of n minus 1, right? N we know is 2. Factorial function, we are invoking this function within the function. That's what the recursion is coming in, right? It's calling itself, inside itself. And then you return it. Right? You return this value. So what's that? So it's 2 multiplied by the factorial of n minus 1, which is 1, right? Factorial of 1 equals to 1. So you have 2 multiplied by 1, and you return it. So if n equal to factorial of 2 is equal to 2 multiplied by 1, which is 2. So in order to understand recursion fully, you have to understand what's the call stack and how does each function, the recursion function is calling and what it's waiting for, right? For example, factorial 4, what is returning? So if n is 4, it returns, right? It returns 4 times factorial of 4 minus 1, which is 3, right? So in this case, the factorial 4 function is waiting. Right? It's being pending based on whatever he's returning from here, on this one, right? Factorial of 3. Now, we know what 4 is, but we don't know what factorial 3 is doing, right? What's factorial 3? Okay, factorial 3 is returning 3 times factorial of 2, right? So now, factorial of 3 is waiting for the next function, factorial of 2 times 3. We know what 3 is, but we don't know what factorial 2 is, right? Factorial 2 returns 2 times factorial of 1. Right now, factorial 2 is waiting. Ooh. You see now, it's waiting for factorial 1. So what factorial 1 is returning, right? Factorial 1, we know if n is equal to 1, it returns 1. This returns 1, right? So factorial 1 is done. It returns 1, right? And 2 times 1, we're done here. It returns 2, right? If this returns 2, goes to here. Factorial of 2 is equal to 2. Right? Now factorial of 2 is no longer waiting, it's done. Right? This function is done. Right? Factorial of 2 is done, it returns 2. Now 2 times 3 is equal to 6. Right? That evaluates into the factorial of 3 function. Now the factorial of 3 is no longer waiting. Right? Because we know this turns out to be 6. Right? So now at last, 4 times 6 is equal to 24. Okay? So 4 times 6 is this. Boom, 24. And this function is no longer waiting. And it returns 24. It's exactly what we have on our test case for the factorial of 24. So that is recursion for you as an intro. Now you always have to remember on a recursion, always define your base case first. Try to minimize your input, right? So we know that our restriction on our input is n is bigger than 0. So we always find what's the one that's 1 bigger than 0, right? This is 1. So that could be our base case right here. And then you try to evaluate what can we do with the base case, right? Because if n is equal to 1, we always return 1. Now we're on the next case, which is factorial of 2, that we can return 2 times factorial of 1, and so on and so forth. We are always trying to evaluate what's before us, right? And the second thing you have to understand is what is the call stat in the recursion, right? Because the original function is waiting on the inner recursive function that's being called. This has to evaluate first and then return something to the original function. That is recursion for you. We're going to have more examples on recursion. This is just the intro of it. We're going to do more stuff like solving palindromes and depth first search at the end. And we're going to try to solve a lot of different math questions with recursion itself. It's a fun topic, it's a hard topic, but we got to get it done. Alright? So thank you for watching this video. If you find this video to be helpful for you, please like, subscribe, and share with your friend. Okay? Happy coding!